Let's look at number 26 on page 162 of your textbook for an example of using variation of parameters to solve a non-homogeneous linear differential equation. So number 26 has y triple prime plus 4y prime equals secant of 2x. So recall, but to be able to solve this type of equation using variation of parameters, the first thing we have to do is find the complementary solution, which is, of course, the solution to the associated homogeneous equation. So the characteristic equation would be our m cubed plus 4m equals 0. That factors as m times m squared plus 4, which gives us solutions of 0 and plus or minus 2i. That tells us, of course, that our complementary solution then is c1 plus c2 cosine of 2x plus c3 sine of 2x. So we've got our fundamental set. The functions that set up make up our fundamental set are 1, because that's c1 times 1, cosine of 2x, and sine of 2x. Our non-homogeneous function on the right, the function that's on the right-hand side of our non-homogeneous equation is secant of 2x. So remember, with the method of variation of parameters, we're looking for that u1 and that u2 and that u3, so that when we multiply them by each member of our fundamental set, we get a particular solution to the non-homogeneous equation. So let's switch over to GeoGebra to help us with this particular problem. So switching over, we'll define our f of x to be just 1, our g of x to be cosine of 2x, and our h of x to be sine of 2x. So we also need to define a function for our right-hand side of the non-homogeneous equation. So in this case, I'll refer to it as j of x, and that is, if we recall, secant of 2x. All right, so now we'll set up our matrices that we'll use to solve that system that we created with the variation of parameters using Cramer's rule. So our original matrix will be f of x, g of x, h of x. We'll have f prime of x, g prime of x, and h prime of x, and f double prime of x, g double prime of x, and h double prime of x. All right, let me just move these around here a little bit so that we can actually see. All right, so there's our matrix, and then remember, you want to copy this down. We'll want to copy 3 different times because we need to replace each of the columns with the column that has zeros all the way down, except the last entry will be our j of x. So for this one, we'll do 0, 0, j of x in the first column. Move this out so you can see everything. This one, the second column will be 0, 0, j of x for the second matrix that we copied. And then we'll do the third column of 0, 0, and j of x. All right. We'll declare each of these as matrices. So here's the first one. We'll call M1. Here's the second one. We will call M2. Here's the third one that we'll call M3. And here's the fourth one that we'll call M4. So we've defined each of those as our as matrices so that we can use Cramer's rule to solve. So to figure out what our U1 is, remember that we'll use that second one that we called M2 divided by M1, the determinants of each of those to get our U1 prime, so on for U2 prime and U3 prime. So let's do determinant of M2 divided by determinant of M1. Let's copy this. Maybe I'll copy this down so that I don't have to retype it all. Make this an M3. Do the same thing here. Make this an M4. All right. So remember again that this, using Cramer's rule, this one here gives us our u1 prime. This one here gives us our u2 prime. This one here gives us our u3 prime. So we need to integrate each of those. So let's integrate number 5. Let's integrate number 6. And let's integrate number 7. Each of those are integrated quite nicely. And now we want to take our number 8, multiply it by f of x, add our number 9, multiply it by g of x, add our number 10, and multiply it by h of x. It's a little ugly. Let's see if we can simplify this a little bit better for us. Let's simplify number 11 there. That didn't make it any better, but let's see if we can pick out some pieces that will help us. So let's go back up to this line here. Let's see if we can pick out some pieces from this line here. See if I can copy this over to the notepad. Maybe we'll see it a little bit better. Nope. Let's see here. Let's undo that. We'll go back over to our GeoGebra here. All right, we'll just do this the old-fashioned way and look at it and copy it over. Okay, so let's look at this first term. This is pretty straightforward. This is negative 1/4 x cosine of 2x. So let's just write this over here. So our u2 must have been negative 1/4 x cosine of 2x. I'm sorry, that is not u2. That is u2 times cosine of 2x. All right, so let's go back over to GeoGebra again. Let's look at this piece here. Notice that we have sine of 2x times this longer expression here. Let me write that over there. We have, so that would have been our u3, by the way. That was our u3 times sine of 2x. I apologize. Would have been 1/16 natural log of what it had, what, negative sine squared of 2x plus 1, and then times sine of 2x, I believe. Let's go back over and make sure I wrote that down correctly. Looks like I wrote that down correctly. All right, so let's see if we can do a little bit of simplifying. Maybe a little bit smarter than GeoGebra for us for some simplifying. Notice that the inside here is 1 minus sine squared. So I could write that as 1/16 natural log of cosine squared of 2x times sine of 2x. And then, of course, if we remember our properties of logarithms, I can bring that exponent down in front, and we end up with a 1/8 natural log of cosine x, and then times the sine of 2x. So we can simplify that one a little bit nicer than what GeoGebra had. So let's see if we can do the last one. This last one, we have kind of a mess, but let's see if we can figure it out. So it's this whole long expression here with the 1/4 and then this, what's inside parentheses here. Let's see if we can get this copied over to GeoGebra successfully. So we have our u1 was 1/4 times a 1/8 natural log of sine of 2x. Was it plus 1 over sine 2x plus 2? Yes, okay. Plus 1 over sine 2x plus 2. And then it was minus 1/8 natural log of sine of 2x plus 1 over sine of 2x. I get this erased. Minus 2. All right, so what do we have here? Let's double check, make sure I have this right. Good. I'm not going to worry about the absolute values. We're going to use solutions that don't have negative values in here. I'm not going to worry about those. But we do have a minus, which tells us that we should divide. So let's go ahead and do that. We'll pull the 1/8 out, make it a 1/32, and we'll have natural log of sine of 2x plus 1 over sine 2x plus 2 over sine of 2x plus 1 over sine of 2x minus 2. On an exam, if it's this messy, we can leave it. I just want to see if we can get this in a little nicer form so that it's not so ugly for us. What GeoGebra put out there for you for your particular or your solution to this homogeneous equation is perfectly fine. You would need to write it down on your test. That would be fine. It's just I just want to see if we can get this a little bit nicer because it's really kind of ugly. So let's see here. Let's see if we can multiply top and bottom by sine of 2x. Maybe we get a little bit of help there to clear out those fractions. We would have sine squared 2x plus 2 sine 2x plus 1. And then we would have sine squared of 2x minus 2 sine 2x plus 1. And lo and behold, both of those factor as, looks like 1 plus sine 2x squared, and we also get a 1 minus sine 2x squared. So I could pull out the square and bring it down in front. That gives us a 1/16 natural log of 1 plus sine 2x over 1 minus sine 2x, which looks a little bit nicer. We could even make this even nicer if we multiply top and bottom by the conjugate of the 1 minus sine 2x. Don't necessarily need to do that because it's not really going to help us all that much. So we'll just leave it at this particular point as our u1. And remember, that was the one that was times 1 anyway. So going back to the original part, our y would be c1 plus c2 cosine 2x plus c3 sine 2x. That was our complementary solution. And then we would have our u1 times 1, which is the natural log of 1 plus sine 2x over 1 minus sine 2x times that 1/16 out in front. Let's go back and grab our u2, which was negative 1/4 x cosine 2x. And let's go back up to our u3, which was the 1/8 natural log cosine x times sine 2x. And that would be our final solution to this equation. Again, the simplification was a little ugly, but again, on your exam, I would not expect you to rewrite this as some nicer form, which is what we did here. We spent a little bit of time on that, but make sure we concentrate on getting our u1, our u2, and our u3. Again, if we switch back over to GeoGebra, those are right here in line 11. That's highlighted here. You can see here was our u1 times, excuse me, this is our u2 times our cosine of 2x. This was our u3 times the sine of 2x. And then this one over here was our u1 times 1. So you could just write that out and not have to worry about trying to go through all that simplifying that we did.